43. To approach the runway, a small plane must begin at 9-degree angle of depression, starting from a height of 1125 feet, or 1,125 feet, above the ground, to the nearest tenth of a mile. How many miles does the plane have to travel to get to the runway? So again, we start this problem off, and I think the biggest issue here is to make sure you draw the picture correctly. We know we're going to deal with some sort of triangle here. So I'm going to draw some sort of triangle, right triangle. And it says a small plane must begin with an angle of depression. And remember, we said angle of depression is the same thing as angle of elevation. If you are having issues with this question in regards to angle of elevation and depression, I go through a much more thorough explanation of depression and elevation in some of the other videos, including the previous problem, number 42. So maybe you want to watch the video for question number 42. All right, and let's go back to this one. It says starting from a height of 1,125. So the height would be 1125. Okay, and actually, you know what? Let me go ahead. This is the depression that they're talking about, which is the same thing as this angle, which is 9. I should have labeled it 9 degrees. Okay. And it says to the nearest tenth of a mile. How many miles is the plane? How many miles does the plane have? I just realized there's a typo there. Have to travel to get to the runway. So this is tricky, because the first time I read this question, I honestly thought it was going to be this horizontal value, but it says, does the plane have to travel? The plane hopefully is not traveling this distance. If it is traveling this horizontal distance, this ramp is not doing its job, right? It's traveling up here. So this is what we're looking for. And I'm going to call this, I'm going to call this R for runway. Okay. This is me being picky here, but the reason why I didn't call it X is because we usually refer to the horizontal as X. You could call it as X, but I was just thinking about that, so I'll call it R for runway. All right, so if I'm giving you the opposite, and clearly the hypotenuse, because this is a 90-degree angle, then opposite over hypotenuse is sine. So we just say sine 9 equals opposite 1125 over R, hypotenuse. So there you go. Like we said before, if it's on the bottom, then if the variable's on the bottom, then we can switch these. And I can say R equals 1125 over sine 9. And then I solve. So take out the handy-dandy calculator. Keep in mind that it said to the 10th, so I'm going to hit mode. And I actually forgot in the previous problem not to change it back, but it wants 1, so I'll change it to 1. Note also when I was in mode, I was in degrees. And so I just go through and I solve it. So I'm just typing this value into the calculator. So let me just, I guess, put the calculator here, clear. And we're going to type in 1125 divided by sine 9. It's always weird when it's just like a random number. Sine 9. Boom. 7191 or 7,191.5. Looking at my answer choices, that is D. Fantastic. I'll see you in the next video.